We're going to take up this problem. A point is 35 mm below HP, 20 mm behind VP, and 25 mm in front or behind or from RPP. Draw its projections and name the side view. So this is a case wherein it is a below HP. So that means the horizontal plane below, and 20 mm behind VP. So behind VP is here, this distance. So naturally it will be in the third quadrant. So that means you have 180 degree here, that is the horizontal plane, and you have 270 degree here, which will going to be, that is from the horizontal, if you measure, this will going to be the 270 degree. So the angle between 180 to 270 degree will going to be the third quadrant. Now when you look from the front view, the image what you are going to get in the front view is the vertical plane, because the vertical viewing direction of the front view will be perpendicular to the vertical plane, and then the top view is viewing direction is perpendicular to the horizontal plane, and again we have the right profile plane. That means when you look from the front view, the profile plane is towards the right side. So that is the reason why it is the right profile plane here. So to view this image on the right profile plane, we have two viewing directions, because these two viewing directions is perpendicular to left side view and as well as the right side view. So when you look from the left side, now we need to decide which viewing direction which we need to be considered, whether it is the left side view or it can be the right side view. So the condition we have to consider is behind VP. So behind VP means it should be behind RPP. So behind RPP means it should be the right profile plane. That is the right side view which you need to be considered. But we will go to analyze this now. So the first condition, that is the condition of the observer. When you look from the front view, the plane is between the object and the observer. Similarly, when you look from the top view, again the plane is between the object and the observer. Then when you look from the left side view, object is between the plane and the observer. And when you look from the right side view, plane is between the object and the observer. So always it should satisfy the condition of the vertical plane. So that means when the observer is looked from the front view, the plane is between the object and the observer. The same condition has to be satisfied. If this condition has to be satisfied, then I have to look from the right side view, because in the right side view is plane is between the object and the observer. So this is how we will be able to say. So when you are looking from the right side view, the object, that is the point, is behind RPP. So in the earlier stage itself, we told that it is behind VP means behind RPP. So the same condition has to be satisfied. So that is how we will be able to analyze which side view need to be considered. So the condition of the problem will going to be remodified, which is or redefined as 35 mm below HP, 20 mm behind VP, and 25 mm behind RPP. Now we will going to solve this problem. So when you take the 35 mm below HP, so below HP distance, which can be this distance, will be seen in the vertical plane. So that means always when the distance is given with respect to HP, it has to be taken in VP. So we can see the image is the front view, because the image is in vertical plane. Now when you look from the front view, you can see the distance below HP, which is 35 mm. So that image will going to fall on the vertical plane. You can see the distance is 35, which is shown here. And also, since it is the image of the image what you are seeing is from the front view, so obviously it will going to be P dash. Then when you look from the top view, we can see the distance 20 mm behind VP. So this distance is the 20 mm behind VP. When you look from the top view, that can be projected onto the horizontal plane here. So the distance is given with respect to VP. Always we have to take it in HP. So in HP, you can see the distance of 20 mm will be behind VP. Now the condition of 25 mm in behind RPP. So behind RPP, when you look from the front view, you can see the distance behind RPP. So that image will going to fall on the vertical plane, because you are looking from the front view. And similarly, when you look from the top view, we can see the distance behind RPP. So that distance, when you're looking from the top view, the image will going to fall on the horizontal plane. So this is how, whenever the distance is given with respect to the profile plane, in general, it can be taken in both VP and as well as HP. That is only because we can see the distances with respect to behind VP, behind RPP is seen in VP and as well as in HP. So this is how we can be able to analyze this problem in 3 dimensions. But when you look from the right side view, we can see the distance below HP, that is this distance, which is 35 mm. And also we can see the distance behind VP, which is the distance which is equal to 20 mm. So that distance can be seen here. So when you look from the right side view, both front view and as well as the side view will going to be on the same line, and that means that is here in the side view we can see this is behind VP and this is below HP. So that means the distances of both front view and as well as the top view can be seen. Now we will going to cut the plane here and then rotate the horizontal plane to the top and right profile plane to the right side. So vertical plane is here, vertical plane is always fixed. Now we will go to the next position, wherein both the horizontal plane, vertical plane and right profile plane is rotated by an angle of 90 degree with keeping vertical plane as fixed. Now when HP is rotated to the above, so HP will going to become above the vertical plane, and the vertical plane will be fixed one, which will going to be below the horizontal plane, and the right profile plane is always adjacent to RPP. Now we will going to analyze this problem as we have rotated. Also correspondingly the images which are there in the respective planes are also being get rotated. So that means when you see the distance below HP, so that can be seen in vertical plane. So you can see the distance below HP, which is 35 mm. Since the image is on vertical plane, it is P dash. Then the distance behind VP, the behind VP distance is seen in the horizontal plane. You can see the distance behind VP can be seen in HP. So that distance is 20 mm. And the distance with respect to the profile plane, so that is behind RPP, can be seen in VP and as well as in HP. And when you look from the right profile plane, both P dash and P double dash will be on the same line. So here you can see the distances of both front view and as well as the top view. So the front view distance of below HP of 35 mm can be seen here, and the top view distance of behind VP can be seen here, which will going to be the in the profile plane. Since it is behind RPP, so obviously this will going to be the right side view, so you mark this point as P double dash. So here when you are transferring the distance of the top view, when you are projecting this till to the end, so this distance will going to be 20 mm, which is vertical here, and the same 20 mm will also become 20 mm here, which is vertical. Then draw a 45 degree line with respect to that vertical line, so that this distance of 20 mm is transferred into horizontal, so that will going to become the top view. Where the front view is there, on that line you will going to get the side view. So then you draw a projector from here, so that it will going to meet the projected point from P dash, so that this will going to become P double dash, and then the name side, the side view, this will going to be the right side view. Since it is the right side view, obviously the point capital P is behind RPP. So this is how we will be able to analyze the in the 3-dimensional sketch. Now we are going to solve the problem using the sketchbook. So here first we are going to draw the XY line and then X1 Y1 line with the thin lines and mark XY and X1 Y1. Then you identify the planes. The horizontal plane is above XY line, so HP is above XY line. The vertical plane is below XY line, so the vertical plane is below XY line. And the vertical plane is always right profile plane is always adjacent to VP. So since VP is below XY line here, so you mark the distance here also RPP below XY line. But RPP should be adjacent to VP. Now first distance behind RPP, which is 25 mm, can be seen in both HP and VP. So from X1 Y1 line you measure the distance of 25 mm, and from here also in horizontal plane also you measure the 25 mm distance, and then draw a vertical projector with a thin line. So then the distance behind VP, which can be seen in HP. So behind VP means HP is above XY line. From the XY line you measure the distance of 20 mm and then mark that point, which will going to be small p, and then distance below HP, which is below HP distance can always be seen in the vertical plane, so which is the front view. So from here you measure the distance of 35 mm and you mark this point, which will going to be P dash. Then draw a horizontal projector from the front view to the side view, because in the side view we can see the distances of both front view and as well as the top view. So it is in the front view, it is below HP by 35 mm. So even in the profile view also, the distance of 35 mm below HP can be seen here. That is the reason why we are drawing a horizontal projector directly here, which is parallel to XY line. So then this distance is 35 mm here, so this distance will also become 35. So we have transferred the distance of the front view. Now we need to transfer the distance of the top view. To transfer the distance of the top view, the top view distance of 20 mm, which is above XY line, which is vertical, has to be transferred onto this horizontal distance. So you draw an inclined line at an angle of 45 degree adjacent to the HP, and then you draw a thin line of 45 mm, then measure an angle of 45 degree and mark this 45 degree dimension. Then draw a horizontal thin projector onto this 45 degree line. So what happens is the distance behind VP, which is 20 mm, will become when it is projected onto 45 degree line, will become horizontal. So this distance will going to be 20 mm. Then draw a vertical projector from here to the where you are projected from P dash, the horizontal projector which is drawn from the P dash to the profile view. Both will going to intersect at this point, and you mark this point as P double dash, and since it is the behind RPP, so obviously it's going to be the right side view. So this will be the final solution which has to be written in the sketchbook.